Hello, this is Max Sims with InnoGov. I'm the CTO of InnoGov, and we're recording this short video to kind of give you an overview of our solution for digital verifiable credentials. So we're going to mostly use the flow diagram in our proposal, if you've already seen that. But we will be talking through that diagram here in some of the different aspects, some of these specific flows, point out a few things, talk about what our solution does. One other thing I'll just point out really quickly is the color guide along the top helps you kind of identify what steps of these different flows kind of belong to different pieces of the overall process. Okay, so first we're going to talk about where do these credentials come from, or where do we start from? And fundamentally, we're going to start with a user going to a website or going to an agency where they need a credential of some sort. In this case, someone wants to get an OHV certificate to be able to use their toys out in the wilderness and have fun, and they need to come to the Utah DNR's website to get that. So they're going to go and come to the site, start their application process. This is going to gather a bunch of information that is going to be used for that credential. And where that's going to go, though, is what's going to be used to be able to create the credential. Right now, it's whatever credential these various agencies are creating. In our process, what we see is that when we go to create a credential, the citizen is going to visit a website. They're going to go in person. There's going to be some requirements that may be satisfied. They're going to provide some information to apply for that credential. Whatever agency or entity is going to do their own saving of that data. But in our proposal, we will have a credential service that will handle the creation of the digital verifiable credential. And so it's going to send some of that information to us. One thing I want to mention here in this step of it is we want to encourage the entities that are utilizing this to really boil down what is the bare minimum they really need to have on a credential, and as much as possible not place things in the credential that would be considered PPI or personal private information, to make it so that that credential is as portable as possible and avoids as much privacy concerns as possible. But as we can see here, I think in this particular case here of the DNR, they're asking for a date of birth. They probably have that for some requirements they need to satisfy, but it's not really necessary for the actual credential itself. So there could be information that is gathered in the process of qualifying for a particular credential that entity may hold on to, but may not be necessary to be passed on to create the credential. After that information is sent, and then we create the credential, we're going to return some stuff back to them, and we'll look at what that is real quick here. So that could be a certificate of some sort that could be printed out, but it's also going to include some details in it. It will include like this QR code here. This QR code actually encapsulates the full sum of the digital credential, including its proof. And then we would also provide a link to instructions on how, if someone wanted to, they could actually manually verify the credential without necessarily using the verify tool that we'll talk about in a minute. So this will be one potential artifact that could be returned from the credential service. This would be kind of up to the issuer on, what they would like to see. Potentially a credential card could be part of that with, that same barcode set on it. Just kind of depends on, what they would prefer. So let's take a quick look to see what that process looks like as far as when someone goes to actually verify their credential. They need to use it somewhere. Okay. So the holder is going to present that in one form. One process would be digitally. So that could be that they are uploading it or they're emailing it, but that involves the verifier having that file. And we can quickly look to see what that might look like here. We got an example of how this verifier might behave. Just 1 second. Here we go. So I could take and drag a file onto here, and the video is probably not recording that piece, and it would go through the process of pulling the information out of that file, verifying it, and presenting the result here, giving us a link to where the hash of that credential is stored on the blockchain. Okay. Another way that this can be done as well is if we're going to be doing this in person. Very similar kind of thing. The holder is going to present their credential. The verifier is going to use that. In this case, if it's physical, they could use a mobile app to do that, and it might have this kind of experience where they take the card, they scan that QR code on the back, and that app then does the same thing, pulls information out of there, comes up with a result there for them to have confidence that that credential is accurate and authorized. Okay, so let's look at what that process of actually verifying that credential looks like here. So we start off, same thing, whether it's the file or scan the QR code, we're getting the same set of information. The file itself will have this information as part of the metadata on it, or it will be pulled off of that QR code. And the file has some distinct parts to it. Has basic kind of the base part of the credential that has, its ID, some metadata around what kind of credential it is, when it was created, if it expires, when it expires. Then it could have some extended information. This example here might be if we used a credential for a voter ID or voter registration. Everything here in the yellow box represents kind of the core credential. We use that to then use public-private key encryption with a private key that will take that file, sign it, come up with a signature that then gets added in this proof section of the file. That gets added to the core credential set of information, these other pieces, to become the verifiable credential. Without this proof thing, you certainly have some information that says, here is a credential, but it's not provable to say, yes, that is authorized without this proof section. And one of the things that is going to be in this is you have a URL that tells it where to basically get that key to be able to do that decoding. And so one of the steps of the process here is after the tool has pulled all the relevant metadata pieces out, it's going to go get that public key that comes from the agency and then use that to verify that signature that's in the proof. And then it knows, okay, I know that this data here is accurate because only this entity could have provided me with this signature that matches with the data that's up in the credential part of the file. Now, one scenario that may come up is you could have something where, say, a credential gets revoked. Okay, well, if we have this credential file that's now been sent to the holder of the credential and they have it somewhere, but something happens to revoke it, they're still going to have the original version of that credential that has no information about that action that's happened. This is where we utilize the blockchain aspect of this. So when we create that credential, we also put a hash reference of it on the blockchain. What that enables us to do is, first, it forever establishes that this credential exists. So it's this immutable record that the credential does exist. But then if things are changed on the credential, the system can go provide an add to the blockchain to say, here are additional updates to this particular credential. And when the verification process happens, it can go ask the blockchain, hey, does this exist on the blockchain? The blockchain goes, yes, it does. And here are all the blocks that go along with that hash. And like one of them could be, hey, this credential was revoked 2 weeks ago. Then the verifier knows, hey, I can see that the actual credential is valid. It's authentic, but I have now additional information that tells me, even though it's authentic, it has since been revoked, so I need to act appropriately. And then obviously the last step of this is the verifier is going to present that data to the who's looking to verify that credential. Okay, let's see here. Now, certainly there could be people that they want to do their due diligence and they want to know for sure that all this is accurate, and they're not going to trust a tool that is going to do all of the verification steps for them. They want to do it themselves, and that's great. That's fine. That's why we have a link to instructions on how to do the verification process manually. It does require a little bit of software to be installed. You have to have like OpenSSL. You have to have tools that can deal with cryptographic keys, public and private keys. And so, but it would basically still be the same process. They would extract the information either out of the file or off the QR code. They would take the various pieces of it. They would go get that public key from the URL that would be on a well-known website. We envisioned that we would encourage the state to have a central repository of these agency public keys. So regardless of what credential you may be verifying, it's going to one central place to get those keys to verify. And that would just be a download. It wouldn't be logging anything. It wouldn't be sending anything to say, oh, we're trying to verify this credential. It would just be, I need this public key. So it would be, still protecting privacy with that. The verifier would then pull the credential chunk of the file, would use cryptographic tools like OpenSSL to take the signature and use that to compare it against that credential and verify that indeed the data in the credential was created and sent by the issuer because they can trust that public key that they downloaded. Then they would also do the same thing. They could use the blockchain URL. They can hash the credential part of this so they can match it. They don't necessarily have to trust the URL that's included with the credential. They can go look it up themselves. None of the stuff that we necessarily provide do they necessarily have to trust. They can independently trust all these pieces. So they can look on the blockchain. They can see that it exists. They can see if there's any updates. And then they know for sure that they can fully trust the data that's included in that credential. So that's that. Now, one last thing I quickly wanted to mention. As you've probably read in our proposal, we are proposing a central credential management service. We think, at least initially for this pilot, that's going to be a good way to go about handling this for quickness of deployment and ease of management, and it will reduce the potential burden on any agencies that want to participate, because it would just be a matter of them implementing some API calls to our service to send information over to get the credential and get the result back, and then also to be able to do any updates. Now, with all that being said, we would have a full API for them to be able to integrate with. We also would provide the ability for them to use an admin interface as well. I'll quickly show you what that might look like. So here we would have a potential admin interface. These are obviously just very sample data right now, but they could search for a particular thing. They could see the details on that if they needed to, make an update to stuff to say, oh, this wasn't actually Gregory, it was Greg. Or we could say, well, actually this one hasn't expired yet, it's still active, and we can make those changes. Obviously, exactly what this admin would need to be would be fully discovered and expanded upon and fleshed out as we go through the pilot discovery process. But that is our presentation for the digital verifiable credentials. And we believe that we have a great solution. One thing to mention, and it was also mentioned in our proposal, but all the things that we're doing here are based on a W3C recommendation around digital verified credentials. We believe that's actually a very good standard, and that definitely should be used. It's going to provide the best interoperability and future support in other tools and stuff that may come around to be utilizing and supporting a digital verifiable credential ecosystem. And I guess one other thing I'll mention real quick too before I wrap up. We did have a pretty good amount of discussion around securing these credentials on the user's end. And there was it seemed to be alluded to in the RFP that maybe we needed to be suggesting a particular solution to help users to secure their credentials. At this point, at least, we don't believe that is a wise endeavor for the state to engage in. I think we believe the best option is for us to recommend that users do secure them, that they explore using third-party wallet services and applications and stuff. But we don't believe it would be a wise thing and would bring liability upon the state if they were to specifically provide a wallet solution to the end users. There are lots of wallet solutions out there. We believe that we should probably provide a list of potential solutions that users could explore and review. But we don't think it would be wise for the state to do that themselves. So that kind of wraps up the presentation of this. Please reach out with any questions. Again, my name is Max Sims, the CTO of InnoGov, and thank you for your time.